to another video on network theorems. In this video, we'll be considering mesh analysis. But before we move to the highlights of this video, please do hit the like button so that YouTube can show this video to other people. And please do not forget to subscribe if you have not yet subscribed. Okay, let's proceed to mesh analysis. So the idea behind mesh analysis is the fact that each mesh in a network has its own current. Go any further into the topic, we should differentiate between meshes and loops. You see, all meshes are loops, but not all loops are meshes. Take for example, in this circuit, we can call this a loop, but we cannot call it a mesh. A mesh is a loop that has no other loop inside it. Take for example, this loop is a mesh, 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 and this loop is a mesh. So that's the difference between loops and meshes. Then another concept that drives mesh analysis is Kirchhoff's voltage law. So based on the idea that each mesh has its own current, we can combine that with Kirchhoff's voltage law and develop a system of equations that we can use to solve the network. When we are using mesh analysis, the first thing we want to do is that we want to identify our meshes. Now, in this circuit, we have 1, 2, 3, 4, and 5 meshes. Okay, so we can number that as number those as mesh 1, mesh 2, mesh 3, mesh 4, and mesh 5. We are done numbering our meshes. The next thing we want to do is that we want to assign current to each mesh. So this mesh 1, let's give it current I1. Let's make all the currents flow clockwise. This one, we call it I2, that's the current of this mesh. We call the current in the mesh 3 I3. We call the current in mesh 4 I4. And we call the current in mesh 5 I5. Now, after we've assigned current to each mesh, the next thing we want to do is that for each mesh, we want to write a Kirchhoff's voltage law equation for each mesh. So take for example in mesh 1 now. Mesh 1. We have this voltage V and 2 resistors. Now the current flowing through this resistor would be I1. Then we say I1 R1. Then we come to resistor R5. Now the current flowing through this resistor is I1. Then we also have another current interacting with it from the second mesh, that's mesh 2, which is I2. As you can see, these two meshes oppose each other. I1 goes in this direction while I2 goes in the opposite direction. So we can say that plus I1 minus I2. Then we multiply it by R5. Okay. Then we come and add the voltage, which is minus V1. And by Kirchhoff's voltage law, we equate everything to 0. We can then proceed to mesh 2 and write KVL equation there. So in mesh 2, we have this resistor R2. IT is flowing through it, but it is also it's also interacting with mesh 5. So the current I5 is also flowing through it, but in opposite direction. So we have I2 minus I5 multiplied by R2, then plus V2, which is a dependent voltage source. Then we have this one plus I2 minus I1 multiplied by R5. Then we equate it to 0, and that is the equation for the second mesh. We then wanted to write the equation for the fifth mesh, that is mesh 5. We will then say mesh 5 so we have the current flowing in this direction. So the first current is the first voltage drop is I5R7, I5R7. Then the current I5 flows through this resistor R3. Then R3 opposes the I5 current. So we have plus open bracket I5 minus I3 multiplied by resistor R3. Then we proceed to this last resistor in the mesh, which is plus I5 minus mesh 2 I2, then multiplied by R2, and that would be equals to 0. And that's how we write KVL equations in mesh analysis. Now, by the time you're done writing the equations for each mesh in a circuit, you would have enough equations to solve for each mesh current in the circuit. And then the current flowing through a particular resistor will be the sum of the currents in a the sum of the currents in the meshes that it is connected to. Take for example, after we calculated the value of the currents from I1 to I5, with the current flowing through R5 would then be I1 minus I2. In this case, we are assuming that the current is flowing in the direction that I1 is flowing in. If the answer is positive, then that means we have assumed the correct direction. If the answer is negative, then that means we assumed the wrong direction. Then the current is flowing in the direction of I2. So the sum of the difference of the current can determine the value of the current flowing through the particular resistance, or resistors that do not interact with more than one mesh have the resistance, the current of the mesh. Take for example resistance R1. The current flowing through resistance R1 will be I. The voltage drop across each resistance in the network would be the product of the currents flowing through the resistance and the resistance. Take for example I2. The voltage drop across it would then be I2 minus I5 multiplied by R2. And that is how we would calculate the voltage drops across each resistor in the circuit. And that will be all about our introduction to mesh analysis. In the next videos, we will be solving our problems on mesh analysis.